This video demonstrates the capability of DEMI, one of the horse platform components, to quickly detect a DDoS attack so that to prevent NTP amplification. In the testbed shown in this image, we have a 5G network with an NTP server component. There is the attacker and the victim. The attacker will be the one who inserts the victim's IP address as the source field of the NTP monlist queries towards the NTP server. In the testbed there are also several horse platform components such as preprocessing, DEMI, DTE, and IBI up and running. DEMI component has already been trained on 21 days of historical data for the NTP server, using NTP no-attack data. Horse can prevent NTP amplification attack because it monitors upstream NTP monlist queries rather than downstream large response packets, significantly reducing detection latency. NTP monlist messages incoming to the NTP server are collected using FileBeat and then passed to smart monitoring, which stores these data in the Elasticsearch. This allows another horse platform component, named preprocessing, to read and process the data. The preprocessing aggregates incoming NTP monlist messages addressed to the NTP server into 2-minute time bins. Every 2 minutes this information is sent to DEMI, which elaborates it with its 2 hierarchical levels of machine learning and obtains an accuracy level indicating the possible risk of an NTP amplification attack. The results are then sent to DTE component. DTE handles this information and relays the appropriate intents to IBI, that, based on the received intent, decides on the consequent action, for instance, a mitigation action. So the 4 components involved in this demo are preprocessing, DEMI, DTE and IBI, green-colored in the flow image. The display here is arranged in 4 quadrants, each dedicated to a specific horse component whose interactions we'll demonstrate. The top left quadrant refers to preprocessing, the top right to DEMI, bottom left to DTE, and bottom right to IBI. In this video we will show how the preprocessing constructs a message containing NTP monlist packet counters and delivers it to DEMI. Then you will see that DEMI receives it and, after a few seconds of computation, sends the result to DTE, which in turn, sends the intent to IBI. Now we'll watch the message flow among the 4 components during a non-attack run. In this green box you can see that the preprocessing prepares and sends to DEMI the NTP monlist packet counter for the NTP server, and the value is 34, which is in line with the expected trend. Now, in the upper right quadrant DEMI has received the value 34 that is the counter of monlist messages received by NTP server and it is currently processing this information through its 2 ML layers. DEMI has finished its evaluation and in the green box you can see the result of DEMI's processing. As you can notice, in this case the accuracy is 0.0, which means that the prediction computed by DEMI based on the value sent by the preprocessing step matches the expected value. Now focus on the DTE. In the green box, we've zoomed in on the DTE log. It shows a prediction 0.0 received from DEMI. Therefore, DTE concludes that there is no attack. And finally it can be noticed that IBI doesn't update any counters in the colored boxes of the dashboard in the bottom right corner. That means no consequent action has been taken. Now the video will demonstrate how an attack is handled by the 4 horse platform components we are analyzing. The attacker depicted in the figure will impersonate the victim by spoofing the source IP address of the NTP monlist packets it sends to the NTP server. Then preprocessing will count these packets and it'll send this counter to DEMI. DEMI will elaborate this input using its machine learning levels and will detect an attack with very high accuracy. It will notify DTE, which will in turn instruct IBI to proceed with mitigation actions. In this red box you can see that the log of the preprocessing component showing that it is sending to DEMI the NTP monlist packet counter for the NTP server, and the value is 47. DEMI is processing the received information through 2 hierarchical machine learning layers and, after a few seconds of computation, prepares the output for DTE, visible in the red box. DEMI has detected the attack, with the accuracy spiking to 0.9, a value that effectively indicates near certainty. This new red box contains the DTE log and shows that it has received from DEMI the attack accuracy information with a value of 0.9. This is an alert. So immediately DTE generates an intent to mitigate the attack towards IBI. Right now, the IBI horse platform component is putting mitigation measures in place to protect the victim from denial of service, DDoS, attacks. The malicious activity originates from the attacker who, as mentioned before, disguised itself as the victim and currently keeps on sending monlist NTP messages to NTP servers. So far, the attacker has not succeeded in inundating the target with such an overwhelming and sustained amount of traffic that it would significantly degrade performance, slow down the system's responsiveness, or ultimately cause the service to crash completely and become unavailable to legitimate users. In the next few seconds, you will clearly see that the intent received by IBI has been successfully fulfilled. On the dashboard, the counter for not fulfilled intents will drop from 1 to 0, while at the same time the counter for fulfilled events will increase from 0 to 1. This change visually confirms that the intended action has been carried out as expected. You will also notice, by looking carefully at the dashboard, that there are no mitigation actions currently running in the system. Furthermore, the mitigated counter, which you can find in the last green square of the threat section, has moved from 0 to 1. This specific change is an important indicator. It tells us that a mitigation process has been executed and completed successfully, addressing the detected threat and confirming the effectiveness of the response mechanism. Once the mitigation action is completed, the NTP monlist packet counters on the NTP server return to their expected levels, while the 4-horse platform components involved in this demo continue exchanging messages. At this point, DEMI correctly concludes with a denial of service attack detection accuracy close to 0.0, and consequently the subsequent components, DTE and IBI, do not apply any further actions. In conclusion, DEMI has demonstrated the ability to promptly detect the denial of service attack, preventing NTP amplification, thereby protecting the network and services. In this video, we've just shown you a well-known attack, but let me underline something crucial. The truly innovative architecture we designed for Horse, it's built around an internal pipeline structure, and this isn't just a technical detail, it's a deliberate choice. The whole system was conceived to maximize visibility across the solution, giving us a broader and deeper perspective on what's happening. And that extended visibility is exactly what makes it so powerful. It's not only effective against familiar threats, it's particularly well suited to detecting brand new categories of attacks as they emerge. In other words, while the example you've seen is common, the architecture behind is future-oriented.